So just like about me, my name is Max, and I worked at General Motors, then Amazon, and now Google. I have like it's over 5 years experience. So yeah, as you can see in this historically accurate depiction of evolution, there was a time before unit tests and before this thing called testing on the toilet. So testing on the toilet, you can see in the lower right hand of the screen this is literally kind of how it looks at Google. When you're using the bathroom, you will be able to read these like little signs that describe best practices. And these articles are all free online. And so, yeah, we'll go over some of those today, and then you can check them out later and just like try and apply them in your code. If you've never seen them, they're like really cool, I think. Yeah, I personally, when I worked at General Motors, there was no unit test actually. And there's no like automated tests. We had like a QA team. It was like pretty hellish. At Amazon, there were unit tests, but there weren't like nearly as many best practices docs there. And so we would like, I kind of mentioned it in this slide, this meme over here asks for code review, does not want to listen to feedback. I'm sure a lot of us have experienced this where, just like we would debate a lot of things during code review. And I think it makes code review go a lot easier if you have like a set of standards that people can agree on. And Google does a lot more of this than at Amazon or at General Motors for that matter. And I linked these other things. These slides, by the way, they are linked in the Facebook event. So you can refer back to them if you want to link. And I link the all the testing on the toilet articles as well in the slides. But yeah, at Google, there's style guides, which are publicly available. There's, this book, Effective Java, is pretty much like taken as the holy law or something, and SRE books also kind of have best practices. And a lot of these are online, are like publicly available. So it can like, yeah, if you want to introduce them at your team, on your company, that could make sense to kind of get people on the same page. And yeah, at Google, I just mentioned too, like during code reviews, we will all review, if you are able to like link this article, then people will generally agree with you and they'll be like, okay, yeah, I'll agree on that, which is, it's great that there are these articles that are everyone can agree on. I think that's kind of hard to do, but whoever wrote them did a pretty good job. So yeah, so you all have experience with this, but there are a lot of crappy unit tests out there. And I think also that writing unit tests is kind of formulaic or turnkey in a way. And so, yeah, I think it's one area where you can have sort of like these rules to help guide you. And yeah, this slide is just kind of saying how, this talk will introduce these ideas, and then afterwards, you won't remember any of this unless you apply it on your own, but you'll have links to the articles in the slides that you can reference later. So yeah, this is what a mock is. I'll go over it really quick because we all kind of know, but this method, the first method over here calls this charity database. And then in the test, the charity database is kind of told what to return. And this line is, setting up the mock. So any questions about that? So yeah, rule number one is, uh, not too groundbreaking, but mocks are good to use, or they're better than, like if you tried to use the real database um, in this unit test, it would be problematic because unit tests, you can have hundreds of unit tests, and they need to be, you need to execute all of them before each change, and so they need to be fast, and they can't be flaky either, right? So you can't have like some of the issues with databases or disks that you would have, or networks, where there's some inherent risk of failure. So mocks also are entirely in memory, and so they solve that problem as well. Um, so that being said, mocks can be overused a lot, and there are better alternatives than mocks in some cases. So, this rule number 3 is prefer fakes over mocks. And we'll kind of go over what I think. I think the terms kind of get confusing, right? Like there's fakes, mocks, and stubs. But the fake is pretty. Here's like an example of what a fake is. It's like a common is, so let's say you have a database, right? And so the fake database will just be it'll use like a map and to store everything, or a hash map, or a hash, it's also called a hash table in some languages. Um, and so this map is entirely in memory, and so it avoids the issues that you see with like a regular database where you have a network call or a disk call. And so it's more suitable for a really fast, reliable unit tests, right? So you can use this fake. So like in the previous code, we kind of told this charity database what to return. And then we call the code that relies on the database. But if we have a fake, you kind of would use it similar to how you'd use a regular database. It would have the same API as the regular database. And you would, yeah. And so in these examples, it looks pretty similar to a mock. We'll go over one example here where it's not, you can kind of see why a fake is better than mocks. Or in a lot of cases, if you have a fake, it's preferable to use that. So test this term, test fidelity. They also introduced this term in this book, which is linked down here, Software Engineering at Google. The test chapters are pretty useful, actually. The rest of the chapters, I don't know. I didn't get as much out of the other chapters, but the test chapters are pretty good. And they introduced this, and it's online. It's free, actually. They introduced this term fidelity, which means when the test is like really imitating the code that you're testing, and it's not like and that's kind of what you want, is higher fidelity, because you're able to check that the code you're testing really works, and it's not like you're just testing something else that's not the code you want to really test the code that you're trying to test, I guess. I don't know how to say that, but we'll look at examples. So like there's this method, set charity efficiency, and this is just the same method from before, where we had that fake database. So let's say now we are checking that the charity name, if it equals null, then we're going to throw an exception. And so just some basic input validation. So this is our real code. Or I don't know, does anyone know like the name for like real code? What would you all call that? Anyone have an idea?
Like calling the actual code? Where is this?
Well, I mean, like, what would you call like non-test code? Just
The code.
non-test. What'd you
Non-test
call it? No
code
test.
sounds
Code.
good. Yeah.
Just regular code. Okay. So yeah, so you're just your code. Well, because your tests are code too, right? So it's like
Yeah, this is true. The code that's
production.
being covered.
Yeah.
Code.
Code under test. Yes. Okay. I was just wondering if there was like a term that I didn't know, but
Oh, can I
yeah,
ask a question?
yeah, definitely. I mean, it's a small group, so
Yeah, so the difference between a fake and a mock is it just that a mock implements the whole thing and the fake doesn't?
yeah, I'm glad you asked. So I think it's kind of usually the opposite way. Um, like usually a mock, you'll call a mock like there's like these mocking frameworks like Makito and stuff like that,
Mm-hmm.
and you'll call a mock like this in your test, or you'll just tell it like what to return.
Mm-hmm.
And so like if you have a service or something, you'll be like, hey, when I provide you some value, then return some other value. And then when you call your code that calls that service, the service knows like the mock version of the service is used instead, and that mock version provides like whatever value that you asked for.
Mm-hmm.
So when you use like a fake, this example isn't that great, but because it's very similar to the other example, the mock, but basically you can use a fake like you can the real thing. I think that's kind of the big difference is like, so this database, the real database has the exact same method, set program efficiency, and you're just using it like the exact same way. So it's really cool. Like, you know, as I both Google and Amazon, they have like these databases, right? That they'll provide, or like, you know, there's just databases that everyone uses, right? And there's also like fake versions of the database that you can use. And it's exactly the same. So like if you try to insert like an invalid value, you'll get an exception, just exactly the same as the real one. And so it's all like the only difference is that it's in memory instead of like on a disk, right? So does that kind of like, do you have any other more questions?
No, that was it. That was perfect
Okay,
answer.
okay, cool. Yeah, and if anyone wants to stop, it's totally. We get Charles posted OpenAI. Okay, yeah, production code. Yeah, I've used the word production code. Okay. So yeah, so maybe we can call this. This is the production code up here. And so we have this validation method. And so here we're just calling this with a mock. You know, we're telling this mock, hey, when someone sets when the program efficiency is set with a null value, then return the success. And so in our test, you know, we can tell the mock to like return to behave in ways that it wouldn't actually behave. Whereas like the idea with a fake is that the fake is going to behave exactly like the real thing. And you know, just like we talked about with the database. And you know, even here I mentioned, you know, how fakes. Oh, I didn't mention it. I deleted that. But fakes can have their own tests too. So they're like very realistic. And this line is just another example of how you could tell a mock like to throw an exception even if it shouldn't. And developers will do stuff like this in tests where they'll like tell tests, you know, mocks to like behave in ways that they really wouldn't in reality. And so, yeah. So let's see. There's other examples of why fakes are important or better, but we don't really have time to go over every example. But you can read more if you would like at some point too. There's the sources down at the bottom. All right. So here's another guideline. Use descriptive test names. And yeah, so the first example is just says, is user logged out, invalid login. And then the second example is user logged out, lockout after 3 invalid attempts. So it's just, the second example is a little easier to understand without actually looking at the code. And I just put here, if other people can understand what your test does without reading the code, then that's a good name, I think. And this meme is pretty accurate that, as test authors, we might think, oh, this test is pretty easy to understand, but then someone else looking at it would be pretty confused. We also have this meme over here. All right, this is the test. On a scale of green to triangle, what's your favorite number of the alphabet? All right, so here we have 2 sections of code. I'll walk through the code and then I'll ask, I can ask you guys which do you think is better. So on the left, there's a setup method. It creates this self.users field, and this comment, the comments in this code are helpful. It says this field can be reused across tests. Then you have the actual test itself here, and we're using a for loop. We're also calling this register all users method, which is down here. And this method, again, can be like reused across different tests. And it also has, this for loop to register each of the users. So then the example on the right, we have a smaller setup method. And then instead of using kind of this like field that can be reused, we just set up each user one by one. Instead of registering users in this like method, we just register them one by one. And then instead of like asserting them in a loop, we just have like hard code, you might say. We hard code these one by one. And so just in your opinion, which do you think might be better? If anyone wants to try.
The one that repeats itself?
Why do you think that?
Because it's clearer.
Yep, that's the basic idea. Yeah, that's right. So it's it's clearer, it's simpler. Like down at the bottom, we have don't repeat yourself, which is kind of this principle that we try and use when we're writing like production code. But in tests, it's kind of recommended that we follow DAMP instead, descriptive and meaningful phrases. Like, and I have this like, I love being #stupid, which is, it's just if you can, developers we make mistakes all the time. Tests don't have their own tests. And so it's important that they're just like really simple and easy to understand. So I think, yeah. It's different than production code, right? It's because we're not, yeah. And so here's this is a separate testing on the toilet article, but it has a similar theme. Don't put logic in tests. And by logic, they mean like for loops or like if statements. And so code on the left has a couple for loops. This isn't like neither of these rules are like hard rules that are always like, I think they're true, but they're kind of like guidelines more than like strict rules. I think it helps to like understand why these rules exist which is to make the code easier to understand. And so you know like when to apply these rules or not, but like sometimes you do need helper methods. But in general, like if you can reduce the logic in a test, then that's a good thing. All right, here's another rule. Test behavior, not implementation. So we have kind of this like calculator. This is the production code that we want to test, and it just adds two numbers, returns an integer. Let's say you've found a new library which can add numbers faster, and so you refactor your code, and now you still have this add method, but it uses like a different way of doing it. The implementation has changed, but the behavior has stayed the same. And so the question is like, does this test, here's our test of the behavior. Does this test actually need to change now that you've refactored it? So it used this new adder factory library, and I don't know if anyone wants to answer or type something or whatever. Do you think the test would need to change? So if you have any questions, please ask. I think it's like totally good to stop and like make sure everyone's kind of on the same page.
Oh, okay. I think it doesn't need to change because it's testing the behavior, right?
That's right, yeah. Yeah, does this example make sense to everyone that we kind of refactored this method, but it still works the same? Okay. Dirk says, don't think so. What don't you think, Dirk?
Oh, I don't think the test needs to change.
Oh, okay. Yeah, so yeah, that's kind of the idea behind this rule is like if you test the behavior, not the implementation, then your test doesn't need to change, right? So that's kind of another rule. And this is like relevant also with mocks and fakes and stuff. We'll see some other ways this can be relevant. So here we have some code on the left. It's user info validator. And it basically just when you get the user info, it checks if the birthday is in the future. And then if it is, it throws an exception. Then we have the code on the right, which calls our user info validator. So when the user info is saved, it calls the validator. And then if there's no exception, then it writes it to the database. And so my question's, do you think we need a test for user info validator if we have a test for user info service? And the last slide does have like a hint. Yeah. So test behavior, not implementation.
I don't think so.
Okay. And why don't you think so?
Because if we're testing the behavior of save and it's like something's wrong with the validator, that should be picked up in the test.
Yeah, that's right. Yeah.
Like, yeah, we should basically in our testing of the code on the right also test that whether validation passes.
Yeah, absolutely. So yeah, in general, this is kind of related to the last rule, and it's just that we can test the public API over the implementation. Another reason why we do this, so like one reason is so that if your implementation changes, your test doesn't have to change. And then, but an additional reason is that, which I really like, is that you're testing the code from the perspective of the user. You're testing, and it gives you more confidence that your code works. So there's these funny memes. I saw a bunch of memes about how you have like a test for like a small part of the code. Like the Titanic had like a lot of a bunch of pieces of the Titanic worked, but then when you put the whole thing together, it didn't work. And there's kind of this idea of like if you can test more from the perspective of the user without getting too big, then that maybe you're testing what you really care about. So it gives you more confidence your code works better. Okay, got some more code here. So I'll just walk you guys through the code and then we can discuss it. Or then I'll ask which option's better. So first line, just instantiates the object. Second line here, it's gonna call actually sort numbers on this array list, which is out of order. And then it's gonna check that the returned list is in the right order, 1, 2, 3. It's also going to check that mock's quicksort was called with this list, which is the list we passed in. And so this other test is very similar. The only difference is you can see it doesn't check that mock quicksort was called. It's just testing if the list is actually in the order that we need it to be. So this one, I think this question's a little tricky, but does anyone want to? It's not too tricky. Does anyone want to like guess which one is correct, is better, and also you can, use the last slide as a hint, maybe.
Option B, maybe.
Yeah, sure. And why do you think that?
Because we want to test the behavior, not implementation.
Yeah, that's right. And yeah, that's basically right. Yeah. I think is that. Yeah, this one. There's maybe a nuance, and I don't or it's maybe this is more of a good way to remember this rule is like testing state can be better than instead of testing interaction. So yeah, this is kind of you're right, Angel, that this is kind of an extension of the last rule, and that you testing what you care about, which is just that the list is sorted. You maybe don't care about whether quick sort or bubble sort was called. At least in this test, you don't care. And a kind of good way to remember that there's like, I'm sure you all have seen this. At least some of us have seen this, where like there will be tests and they'll like check that all these interactions were successful with like all of the services that are called. And sometimes that's necessary, but like ideally you can just check that the result is what you want, because that's at the end of the day what you care about. There's like a lot, and this isn't ideal. I think there's like if you insert some value into a database, yeah, I mean you can, or you just try and check that the result is correct. I think that's the general idea. But yeah, sorry if I'm kind of thinking through this one on my own too on this slide. But I think that there's definitely this preference of like testing the state that this systems do change its state when they run, and so we want to check that the state has been changed and not just and things we don't care about. Maybe we don't care about the interaction very much. or if you did care, like, there's also this like the article goes into this more, but basically like maybe quick sort is faster than bubble sort. And so maybe you do care about that, but then like another test could have test your performance. Right. So anyways. So which example do you guys think is better here? A or B?
Option B.
Okay, why do you think that?
I think it's clearer without the need to have a comment.
Yeah.
Oh, I also think if you go with option A, there's just going to be comments everywhere.
And why do you think comments are less preferable than just like having self-documenting code?
Because a comment is only in one place. The code could be used in multiple places. For starters, like if you see the width variable in a completely different file, or somewhere completely different, you might have to like scroll up and find where's the comment. Is this in meters or something else?
Yeah, that's a great reason. It's like drift or code drift or something like that. Another reason might be that, the comments can get out of date, whereas developers are more likely to update the code. Make sure that's up to date. So, and this rule applies also to like production code, but also to tests. So this is kind of my own rule, but yeah, I think it kind of, and the memes agree with me, to err on the side of adding too many comments usually. There are a lot of times when I find it really helpful to have comments. And I hardly ever look. I mean, sometimes I'm like, hey, this comment, is like this, where it's like kind of useless, but I'd rather have like some useless comments than no comments, which can, in cases where I do actually need a comment. So yeah, I just think I often in code reviews will say like, hey, why don't you add comments, or can you clarify this in a comment or something. It can really, there's been situations where it's really helped to have a lot of comments. Yeah, so I don't know. It's just some thoughts. All right, so we have another test here. Basically, option A is going to assert a lot of things in one test, and then option B is breaking that test up into individual smaller tests. You can look a little bit through it. The code, you have withdraw 5 is okay because on this line you deposited 5. Withdraw 1 is rejected because you only had 5 in there. If the overdraft limit is 1, then it's okay again to withdraw. This code, it just splits things up. So it's testing 5 is okay to withdraw. It's testing that 6 is rejected. And then it's testing that 6 is okay to withdraw if the overdraft limit is set, which is what this last one is doing. So which do you think is better?
Option B.
Why do you think that?
Because it has its test separated. That way, if you can know which of those cases has failed in the option A, it will fail, and you won't be able to know which one specifically had failed.
Yeah, that's a really great reason. So the tests should be orthogonal as much as possible. That's and a lot of you probably heard of this word orthogonal, but it's just basically where it comes from geometry, where two lines don't intersect, and tests ideally should not intersect with each other. And so then, like Angel's saying, if one of them fails, you can tell like, hey, that test failed, you can more quickly identify why that test failed because it's not some other code. You have less code to look through, and they just don't interfere with each other as much. Yeah. It's also kind of goes back to our point earlier about keeping tests simple. It's a lot easier to kind of tell what these tests do just from looking at them. So the rule is to keep tests focused as much as possible. So I have another example here. Yeah, maybe it's okay to just look at the last line of each of these tests and the test name. So option A, display greeting, shows special greeting on New Year's Day. And then it verifies that this prompt was shown, that the title bar had a certain date, and that the prompt style is normal. So this test, option B, same test name as above, but it's only verifying that the prompt contains Happy New Year. These any kind of method calls mean that like anything could have been passed for the title bar and the prompt, and the test will still pass. So it's not checking those. It doesn't care. This test doesn't care what the title bar or the prompt style are. And then this other test has a slightly different name, but it's checking that the test prompt contains hi fake user. And then also it doesn't care what the title bar and the prompt style are. Does this example make sense to anyone, or any questions on this? And then if it makes sense, does anyone have an idea on which one might be better?
Sorry, the part in the middle is part of option B? Just to be clear.
Oh yeah, sorry. Yeah, option B is both everything outside of this box, and then option
yeah.
A is in this box.
Just making sure.
Seems like B is better for the orthogonality reason.
Yeah, that's right. So yeah, this test is more focused, like Nicole's saying, and so you have separate tests for different behaviors, and yeah, it's kind of very similar to the previous rule of keeping your test focused. This is kind of just a more specific rule for that. Does any questions on this one? Or if you want to disagree, that's fine too. Yeah, so just in general, this kind of brings back to the point of just testing things you care about and not testing things you don't care about, and then also just having focused tests. So if you do care about the title bar or the prompt style, you can split those into separate tests. All right, and then we have new example. So kind of similar to the other ones where you have, but this, let me explain also for anyone who's not familiar with Java, this is like a setup method, and this will be called before each test. And so before each test, this tally object, you'd call increment, key 1, 8, key 2, 100, etc. And then, this comment says 200 lines away, you'd have, even though, well, you'd have 200 lines away, you have this test which checks that the tally is equal to 9. And it's relying on this setup method. And so option B, the setup just happens inside of this test instead of in a shared like setup method. And so which one, if you were just trying to understand what this test is doing, which one is easier to understand?
Option B.
Why do you think that?
Because
maybe it's
inside,
hard. Yeah, go ahead.
yeah, inside option B, there's everything you need to know to get the full idea of the test.
That's right, yeah. Yeah, so you don't have to, and this is, you know, even a really simple thing in software is like, hey, don't put the code far away from, you know, like having to scroll to go look up other code is kind of, and you have to keep something else in your mind while you go back and look at it elsewhere. And also brings us to the point we talked earlier about keeping our tests orthogonal, right? Like this setup method is going to be shared between a bunch of different tests. And so if one of the tests fails, you have like all of this code to look at, which could be pretty big. And this is a pretty common pattern in which developers will do is they'll have like one setup method for all of their code. And then, you know, there are, I mean, you do need sometimes shared setup methods. That's not, you know, we're not, that's not like a evil, terrible thing that you should never do. Sometimes, but in general, like if you can break, you know, similar to how you might break production code down into smaller pieces, right? So you can reason about each piece separately.
This is also another case of readability of the reuse, you'd say.
Yeah. Yeah. So yeah. Yeah, that's right. That's right. Yeah. Yeah, you're not trying to like reuse the code a lot to make it more like, that's right. Yeah, that's a good point. Yeah. Okay, we're almost done. This is, yeah, I don't know if which, I'd really be curious to hear too, like y'all experience, your experiences if you want to share anything. We can go back and look at previous slides if you have anything that you thought was relevant to your experiences. But does anyone have like experiences with code coverage at their company? Like, do you have like or at their organization like any target code coverage? So code coverage means usually there'll be a percentage number that you get, and if you have 100% code coverage, that means that every line in your code is covered with a test. So you'd start at 0% and then you'd go up to 100%. But a lot of companies will say like they want at least 80% code coverage or something like, or 90% code coverage or something like that. Does anyone have any experiences with their company, whether like good or bad in terms of code coverage?
Yeah, I had in my current company, we were striving to get the 90% code coverage. And it's like a good way to start creating unit tests. But when you actually go and see what the unit tests are, the last assert was it's not null or something like that. Like that's meaningless. But yeah, you got the code coverage. So it's like it can be beneficial if people are knowing what they're doing. But if it's just to get the code coverage, it makes no sense sometimes.
Okay, yep. Cool. It's a great story. Yep.
Yeah, very similar. At Coinbase, we were striving for 90%. And there were some tests that were consistently flaky. So it was just really like 90% felt like it could be a real stretch sometimes. So I think there was discussion towards the end of my time there about like bumping it down to like, would 89% or 99%, or sorry, yeah, 89 or 88 be better, because people were like, that's so much. It's just like the incremental value of the extra test coverage. It just takes so much more time to get there to 90. So I feel like Coinbase was very like good about testing. At FTX, it will surprise no one to hear that they were very bad about testing, and they literally did not know that you could test the front end. I think like I like described Cypress to them, and they were like, what is that? We've never heard of end-to-end testing for the front end before. So, and there were no front end tests, and there were tests on the back end, but it was much more like, it was just much more like minimal. Surprising nobody. So
Yeah.
that's my experience.
Interesting. Was there any like progress on the flaky test, or did you all figure out why those tests were flaky? Nicole? All right. Yeah, so yeah, I think maybe Nicole, you didn't hear me or something. But yeah, so those are really good examples. And yeah, I think just the number, that's what these articles, which y'all can follow up on if you want. Say it's another interesting point the article brought up is maybe we'll just open it really quick. You know, so usually code coverage is goes by lines of code covered, but if you have something like A or B on the same line, you can cover this by just checking one of the conditions. And so this is something that like at Google, they try and get around. They have, I'm not sure how they do it, but they have like some sort of static analysis tool that can tell you, in addition to like lines of code coverage, it can tell you that like if one of the paths is not tested. But that's kind of another reason why like code coverage lines can be meaningless, sort of. Or not meaningless, but not necessarily like a, you know, an LBL. So yeah, this is kind of one of my favorite rules here. It's new, you know, I've never thought of it before. So you have code up here, which is creating some test data. And when it creates a small company, you can see it passes in to null public, privately owned. You can see it passes in private. And you know, a lot of code will be like this, right? They'll pass in these default values into some sort of like kind of constructor or builder method or factory method. And I kind of wrote this code down at the bottom so you could see an example of what this method might actually look like. Option B, you have like a default value being returned here, and you can see down at the bottom, this like new company method just returns like default values for everything. And then you set up, you know, it's very, very clear. You set the employees and the board members, and that becomes a small company. You know, the private company is private. And does anyone have thoughts on, I mean, I think for this one, I've kind of already said the answer, but does anyone have thoughts on which is easier to understand?
Option B.
Why do you think that?
Because option A, when you look at the null, it isn't immediately obvious what those are.
Right, yeah. And yeah, that's right. Another advantage about this is that like this option B, the bottom one is if you're trying to figure out what like the test as a whole does, and then you see like, oh, the only thing that's being set in this test is like the employees and the board members, then that's like all this test is trying to test against. So I don't know if I said that right, but basically like, yeah, you can kind of like, by leaving certain things out, you can you can indicate to the reader like, hey, I'm only testing the employees or board members, or I'm only testing the private thing, and whatever else that's going on in my test shouldn't depend on these other things that are going on. So it's like helps clarify what the intention of the test is. I really like these like default methods and stuff. I don't know, it kind of clarifies. I'd never seen this like kind of pattern before of having like a default value and then overriding like what the test is actually cares about. I thought that was interesting. Yeah, so this might be a little basic for you guys, but you know, here's an example of like a good test. Yeah, and I think yeah. I wonder, what do y'all think? Like, did you learn, like, was some of this new to you, or like, I mean, I think a lot of it makes sense to y'all, but like, had you seen these these as like rules before, or like, also, what does your company do? Where do they like have a shared, I don't know, how does like code review go at your company? Is it like hard because or could you be like, hey, you should test behavior, not implementation, or something like that? Like, what is your experience there?
Well, at least in my case, on my company, we have code reviews, but we've never actually reviewed unit tests, just production code. And I've never seen the rules written like this before. But they make sense when you put it like that, like that. So I was just when I was starting making unit tests, somebody like explained me, no, don't do this, prefer this, but not with this set of rules. And it makes more sense than having to learn it the bad way.
It makes sense. Yeah, did you do you think the unit tests are like good quality at your company even without the rules, or what do you think? What's your experience?
I think it depends. They are like the before and the after, when they were trying just to complete for the code coverage, just for the sake of the code coverage, and when they actually started to think, what are we testing? And when you look at like those, it's a mixed bag, because you can either get into a file and see the previous version of the unit test and the new version of the unit test. I think the new one has better quality than the previous one.
Cool. That's interesting. Did they just get rid of did your company just get rid of the code coverage metric, or?
It's still in place, but we as developers started to focus more on the quality of the of the unit test rather than on just the code coverage metric.
Cool. There's one thing I want to, because I know we have like 3 minutes left. I want to just plug, and I think this is relevant. Well, yeah, like feel free to still reach out to me if you want about anything. But also this these salary negotiation guides. You know, I mean, this is kind of EA group, and so I want you all to be very rich. So Candor has a really good, and this again, these links to slides is in the Facebook event. Candor has a really good free salary negotiation guide, and also I really benefited a lot from levels.fyi. It's a webpage. They have a salary negotiation service. They also have like a resume review service and some other things, but I think probably most of you all are familiar with levels.fyi. But yeah, I've earned more than $10,000 per year, like probably at least, I don't know, like a lot more than $10,000 a year. And it costs like $500 to do. So it was totally worth it. It's multiple lives saved a year, right? So yeah, just wanted to mention that. And yeah, I don't know. I mean, anyone, you're free to go, or if anyone has anything, if people have to go, I understand. And
Yeah, thank you so much. It's been really great.